Find an equation for the hyperbola described. Graph the equation. So before we solve this question, let's take a look at the two versions of our hyperbola that we're working with. We have a vertical and a horizontal orientation. So in our equation, we have an h and a k, which is the center of the hyperbola. And then we have an a, which is the distance between the center and the vertex. B helps us determine the slope of the asymptotes. And then we have a value of C, which is the distance between the center and the focus. We have those same variables in the other equation, but the major difference is that in the first equation, our x term is positive, but in the second equation, the y term is positive. And that's going to help us to determine the orientation. So when our x term is positive, we have a horizontal orientation. When our y term is positive, we have a vertical orientation. So for the hyperbola, for the horizontal orientation, you have your center, a distance away to the left and to the right. You have your vertices. C distance away to the left and to the right, you have your focus. Your value of B is going to help you determine the slope on your asymptotes. Your asymptotes pass through the center. And then from there you have your hyperbola drawn from the vertex approaching those asymptotes. For the vertical orientation, you have your center, and then up and down from that center, a distance of A will give you the vertices. Up and down from that center, a distance of C gives you your foci. Passing through the center, you're going to have two asymptotes. Your slope of that asymptote, the slope of the line that's that asymptote, is determined by the value of A and B. And then you're going to draw your hyperbola using the vertex and approaching those asymptotes. So for this example, I want to first determine the orientation so that I can know which of these templates to use to start building the equation of the hyperbola. So we have a center of 0, 0 for the hyperbola, a focus at 0, 6, and a vertex at 0, 1. So because all of these important features of the hyperbola are lining up vertically, that means I have a vertical transverse axis, and I'm going to use the vertical orientation of the equation. So in order to find the equation of the hyperbola, I need to know the center, which is hk, and these values of a and b. So I can see that the center was given to be 0, 0. So I know the value of h and k. My focus is at 0, 6. So from the center of 0, 0 to the focus at 0, 6, that's a distance of 6. So the value of C is 6. And then from the center to the vertex, that's a distance of 1. And that means my A is 1. So then finally, I can find the value of B by using this equation for that involves Pythagorean theorem. So I can use B squared equals C squared minus A squared. B squared equals 6 squared minus 1 squared. That's 36 minus 1, which is 35. So B squared equals 35. I'll take the square root of both sides to get that B is equal to square root of 35. We'll use the positive root since B is a distance. And I can substitute this into the template. The vertically oriented hyperbola, or the not parabola, hyperbola that has a vertical transverse axis. That's y minus 0 squared over a squared, so that's 1 squared, x minus h squared, that's x minus 0 squared, over square root of 35 squared equals 1. And if I simplify, that would give me y squared minus x squared over 35 equals 1. So that's the equation of the hyperbola. Then we want to graph that equation. So I'm going to take the sketch that I've already started. If I have a vertex at 0, 1, I will have another vertex on the other side of the center at 0, negative 1. And then I have a focus at 0, 6. I'll have another focus at 0, negative 6. And then I can use my equation here to find the asymptotes. The asymptotes are going to be y minus 0 equals plus or minus 1 over square root of 35 times x minus 0. That's y equals plus or minus 1 over square root of 35x. I need to find an approximation for 35, square root of 35, so I can sketch this. Square root of 35 is approximately 5.9, so almost 6. So I can use rise over run, or rise 1 and run 6, almost 6. And rise 1, so I'm actually going to go the opposite, down 1 and run 6. So that gives me the negative 1 over square root of 35. And if I draw a straight line going through the center and that point, I'm getting my asymptotes. From the vertex, I can approach those asymptotes and get a sketch of that hyperbola. Thank you for checking out my videos. Have a great day.